I'll start with a couple of quick questions just to get a feel for it. How many of you know about what Azure Resource Manager is to start with? Okay, probably about 50% of the room. And have you guys seen any one of the two sessions that Donovan Brown did today, one in the morning and one just in the early afternoon? Yeah, okay. So this session is sort of an extension, or at least covers an extended area of what he was showing with the build and release management capabilities that we have in Visual Studio Online on Azure. And the session is titled Deploying, Organizing, and Securing Applications with Azure Resource Manager. Azure Resource Manager is also known amongst us as ARM, right? The acronym, as if we need another one of those three-letter things. So my name is Emil Velinov. I'm a program manager from a team in Redmond called Azure CAT, or Customer Advisory Team, for the Azure platform, based out of Auckland, New Zealand, and covering Australia and New Zealand in terms of customer projects, opportunities, escalations, you name it. The team is actually part of engineering. We are not part of the consulting, support arm, or any of the business and marketing groups locally. And the reason we exist is, A, to help out customers with complex projects when they face challenges on the platform. And as we learn about those challenges, we bring those, that information, which is quite valuable, back in the form of feedback into the development teams in Redmond, so that the technology moving forward improves and closes those gaps or knocks out those challenges. This is the idea. So the talk around ARM and working with ARM is really very simple in concepts. And as usual, the devil is in the details, right? Once you start working with it, there is, syntax things that you need to figure out what the syntax is and how it works. There is relationships between the artifacts that you are deploying. You need to understand how these things work as well. Of course, we are not going to cover every single syntax-related point today. We are going to cover the concepts, and then I'm going to spend a fair amount of the session time doing demos as well. So hopefully the demo gods are going to be good with me. Fingers crossed, everyone in the room, so that everything works, and we'll see how it goes. So what are we going to actually focus on? The three stages of deploying, organizing artifacts that you deploy in Azure, and then controlling your Azure deployment through that Azure Resource Manager model, right? So, and I'll follow pretty much that sequence throughout the session. ARM, very quick architectural diagram of what the Azure Resource Manager is, okay? So Azure is built out of many different services that perform different tasks and give you value that you put together into a solution. Each one of those artifacts that is part of a solution or components of a solution needs to be managed, and we put an API in front of those artifacts now, or in front of those components. Each component or service in Azure is responsible for delivering their own API. And that API for each component or service in Azure is called a Resource Provider API. This is the bottom part of the diagram here. So you have a storage resource provider, a compute resource provider, a network or virtual network resource provider, a website's resource provider, a SQL database resource provider, and so on and so forth, right? So all the services in Azure should have one of those resource provider APIs. On top of the resource providers, we have a single unified API tier, which is what you guys are ultimately working with, rather than going against each one of the resource providers individually, because you don't want to manage 200 different endpoints, one for each services provider, right? So the Azure Resource Manager is that unified single API for working with the resource providers underneath. It is a proxy, if you wish, in a way. And on top of that, okay, so not on top of that, to the side of that hangs off Active Directory, which is, of course, or Azure Active Directory, which is, of course, used for authentication and authorization purposes for the APIs that you want to work with. And on top of the Azure Resource Manager API, or the ARM API, you have the tooling, right? And the tooling starts from nothing, whereby you just invoke the REST-based API of the ARM service itself, right? Through to PowerShell, which builds on top of the REST API of ARM. Then you have the Azure CLI tooling, which is command line tooling. Again, it works with the underlying REST API. Then you have integration into Visual Studio. And then if you want, you can build extensions or whatever directly on top of the REST API of ARM. So pretty simple, yes? The idea here is that you have a unified way of managing the entire environment. Not nowadays, you don't need to go and manage every one of the services using a different API, maybe different type of codes, different authentication, authorization, and so on and so forth. This is what the value proposition of ARM is. OK, so how do you actually work with ARM? As I said, one of the ways is directly against the REST API, or through the tooling that sits on top of the API. But the other major part of this is templates. So your solution is composed of a SQL DB database. It's composed of a website. It's composed of a cache. There is a way to define a template, declaratively, obviously. This is why it is a template, right? That describes that deployment. And you push that template into the ARM API, which is then responsible for understanding what is described in the template. And then depending on the different resource types or services that are defined in that template through this declarative JSON-based language, the ARM API itself, the ARM service, goes off and automates the resource providers to provision the resources that you've defined or that you've asked for. In a way, the template is effectively a definition of a desired state. Okay? I don't want to say desired state configuration because that may be confused with PowerShell and so on and so forth. It is really just a definition of the desired state for your solution. Okay? And the ARM API takes responsibility of giving you that desired state at the end of the execution of that template. In order for this to work, the template needs to be reentrant or idempotent. This is what that refers to. Multi-service, which means that it works across the range of different Azure services through the resource providers, as we said. What is interesting is that a template definition actually can automate the provisioning of resources declaratively, right, across different regions. So what I'm saying here is that you may have a solution whereby your primary deployment is in the Sydney data center, right? And you have a DR deployment, for example, or just a regional deployment in the States, one of the US data centers. And all of these components can live just in a single template. So you push the template into the ARM API or the ARM service API, right? And 10 minutes later, you end up with a deployment in the US. You end up with a deployment in Australia. They are identical. They are guaranteed to be there for you as long as you got a success status out of that template. And it is extensible, right? So what that refers to is, imagine that your solution heavily relies on infrastructure as a service, virtual machines, right? It is really easy for Microsoft to know exactly what a virtual machine definition looks like. You need some IP addresses. You need a network interface or a NIC. You need some disks. You need the virtual machine with a bunch of CPU cores and so on and so forth. What you actually do inside the machine is not really clear to Microsoft at all. You might be pushing in a Windows service. You might be provisioning 10 IIS websites under IIS. You might be doing God knows what, right? You might turn the server into a file server. So how do you achieve this, right? Through extensions, okay? And we are going to talk about extensions a little bit more. There are different types of extensions that you can, define in the ARM template. And that template will push those extensions into the virtual machines, and they will self-configure, so to speak. OK, so the Azure Resource Manager is based all around the concept of a resource group. And a resource group is, guess what? A grouping of resources. So apart from that, the resource group has some, and the templates inside, have the semantics of defining the life cycle, the deployment life cycle of your solution artifacts. So that life cycle, of course, starts from the time when you go deploy template through to the time when you go delete deployment, right? And when you delete the deployment in the resource group, obviously the artifacts disappear. In the meantime, they are managed by that resource group and the deployments that live inside the deployment, inside that resource group, sorry. Okay, so a few grounding principles is that a component of your solution needs to only ever reside in a single resource group, okay? Of course, you can have your solution spanning across multiple resource groups. We are going to talk about that topology in just a few minutes, okay? But remember that grounding principle, it is really important. A resource group, the third point on the screen, a resource group can span regions. Again, can host artifacts or components of your solution that are deployed to different regions. That's important, and of course, you can have different types of components or services that are part of the same resource group. So then the question, okay, you have that declarative model for describing what the solution looks like. You deploy it, but what if you want to make changes after that, right? Ad hoc changes, so to speak. And the thing is that because we have the REST API, ultimately, it is really up to you to decide whether you want to go fully imperative, fully declarative in the form of templates, or a mix of the two. You start out with a template, and then you start pushing imperative commands against the environment, against the resource group and the artifacts that live inside that resource group. And we have a simple example of that. The top part works through the ARM-based PowerShell commandlets, and the bottom part is the declarative version in a way, or at least the high-level structure of a declarative template. One thing that I want to clarify for everybody, because this is an area of confusion that we have already seen, we have had PowerShell commandlets for working with the service management API, right? In many cases, and the first statement is that the ARM PowerShell commandlets, right, rely on a completely different management service, and this is the ARM management service. However, to make things easy, right, the PowerShell commandlets from the two management models in many cases overlap in names. So in Service Management API, the old style of managing the platform, you have a commandlet called get Azure locations. This is telling you basically what services are deployed in what region and what data center. In the ARM version of PowerShell, you have a commandlet called get Azure locations, right? So you need to be really very careful when you go to MSDN and you just hit MSDN through a search engine looking for get Azure locations. Is MSDN giving you the ASM or the Azure Service Management PowerShell commandlet syntax and subtleties, or are you looking at the ARM-based version of the get Azure locations PowerShell, right? It is just a word of caution from personal experience mostly, actually. All right, yes, pulling hairs out, translated. Okay, so we spoke how a deployment tracks the template execution. So basically, a deployment is when you actually ask the platform to provision the resources from that template, and this kicks off the life cycle for that deployment based on that template. The deployment is created inside the resource group that it describes, and you can have actually nested deployments as long as they live inside the same resource group. And we'll talk about that topology in a few moments as well. All right. So it's time for the demo that I promised. And guess what? I'll actually start with a PowerShell commandlet called get Azure locations. Here is my PowerShell window. So the very first thing that you need to do in order to switch PowerShell from Azure Service Management API to Azure Resource Management API is called that commandlet that we see on screen on top. Switch dash Azure mode Azure Resource Manager. Okay, we'll do that. It's a command that executes relatively quickly. It loads the appropriate ARM modules. Keep going. Okay, clear the screen a little bit. And I'm getting the Azure locations for the different services. It's a long list. On the left-hand side, the column describes the resource provider type. And if you are careful and look through the names, you are going to probably see Microsoft App Service API apps and gateways. And then the third last down at the bottom is actually a third-party provider, which is the sendgrid.email/accounts, and so on and so forth. What we are saying here is that even if your solution relies on SendGrid's send email service, you can put that as part of your ARM template definition. Okay, so just based on that same thing, let me just use that command to see where the storage service is provisioned. So I'm basically saying get Azure location, limit the objects where the name of the resource provider is Microsoft.storage storage accounts, and show me the locations collection property of that object. And we see the data centers or the regions where the storage resource provider API is currently deployed. You will see that Australia is not there. Okay, it's coming. Okay, very soon. We are talking about a few weeks rather than months. Okay, so hang in there. Very soon you will be able to automate. In fact, okay. So this is the other thing that I want to be clear about. The ARM service, the ARM API service, that middle layer in the diagram that we had before. This is GA. It is live in all regions around the world, including Australia. However, the storage resource provider is not deployed to Australia yet. Okay? So if your solution only relies on websites and a SQL database from our PaaS offering, you're fine, because that doesn't touch storage, it doesn't touch virtual networks, and it doesn't touch virtual machines. Those are the resource providers that are still missing to be deployed in the Australian data centers. They are available in those other data centers that you see. So the only ones that are missing are the 2 Australian data centers and Brazil as well. All right, so the next thing that is part of that demo, I want to actually show you a template. So let me collapse a couple of areas here. So this is the simple structure of an Azure template. You have parameters, and parameters are important because this is how you can feed different configuration. Excuse me. You can feed different configuration elements and values into your template depending on the environment that you want to deploy to. The second one is variables, and those are obviously things that will be changing depending on what the input was, but that are internal to the template itself. And then you have resources. This is basically the meat of the template. This is where you define the components of the solution and how those components are configured. Of course, the resources will be configured based on the parameters and the variables that you calculated or derived based on those parameters at the front. So in our simplistic template here, I have a deployment environment parameter, which is of type string, right, with some default value, which is development, and then the allowed values are development, test, staging, and production. You can do whatever you want there. And then the second one is what is the storage account name that this template is going to provision. Obviously, somewhere later, we are going to define that storage account. So variables, I have some hard-coded subnet address prefixes, right? Not really terribly important here for that demo. And then I have the resources. So this is the definition of a storage account that will be created by this template. Let me just roll back, right? So the name at the top, the first property of the storage account, is a concatenation of the VM storage name parameter that we fed in and the deployment. So if I type in Ignite NZ as my storage account name, and then dev. Obviously, the real storage account name that will be provisioned will be ignite nz dev, right? And that is going to be a storage account. We define that the actual physical deployment location of that storage account is the same location where the resource group has been defined, right? They could be different. Remember that resource groups can span regions, but the actual definition of the resource group is deployed to one region. And then you have dependencies, if there are any. In our case, this is a storage account. It doesn't depend on anything else. It is just a standalone entity. You have tags. We are going to talk about tags. There are two tags that we define here. The first one is display name, and the second one environment. And then the account type, which is a property that is specific to the resource provider for storage. Okay? One interesting note here is that the display name tag is the one that becomes visible in the structure window here, or the outline of your JSON-based definition, right? So display name is VM storage, and this is exactly what shows up there. Okay? You can have multiple tags, as we can see here. Right, so let's get going and kick off a deployment based on that template. So I'm going to push that into that subscription, into that existing resource group, which, by the way, is that resource group in the portal, and we'll see that there are no resources inside. So it's completely empty, just a placeholder resource group that I created. The actual deployment can create the resource group as well, so you don't need to pre-create it specifically. Parameters, you can feed them in if you have to, right? And I just leave everything to the default values that come with the template itself. And then we are going to go and hit the deploy button. Immediately at the bottom, you start getting feedback on how that template deployment is going. And eventually, hopefully, if the demo works, we are going to end up with success. And we'll see the resources into the portal. Quick question while it's running. Go ahead.
Why does it say it's deprecated?
So, without scaring you, for the majority of the audience, because eventually the service management API will go away. Or at least we are not investing anymore in service management API, right? So the need to switch mode is not going to be there. But we are talking probably years, to be precise, right? It's not going to happen in 2 months or 3 months or 1 year even, right? Because people still have these things going, okay? Okay, so that specific template is really just the simplest example that I could think of. Deploys a storage account and a virtual network with 3 subnets inside. Okay, so let's go back to the slides. Any other questions, by the way, based on what we have seen so far? Make sense? As I said, it's a really easy concept to grasp until you start crafting the JSON template and figure out what are all the properties that describe a particular type of service component, such as a storage account. It just happens that storage accounts are really simple to describe. You just need to know what type of storage account you need, and that's it, and the name. For a virtual machine, it's not that easy. Anyway, so as I told you, the ARM API service, right, is the one dealing with the declarative template. But the resource providers at the back, they only understand the rest. So the ARM service is the guy that needs to translate the template-based definition that you just fed into the deployment, right, into REST APIs, okay? And if we have a resource, such as a storage account, the equivalent gets and posts to the REST service of the resource provider get translated into something like this, right? The first section is implied, which is based on the type of resource that you are deploying. In our case, it is a storage account, and that defines the prefix of the URL effectively. Then the name of the storage account. Then there is the version of the API, of the provisioning API. Different providers may be versioned. So in other words, they, as the provider API evolves, it will be published out to you in different versions, and you can target a specific version. And then in the JSON body of the post request, or the put request in this case, you have the properties of the object that you are, or the resource that you are trying to provision. The first one is location. We want to deploy to West US, and the account type is locally redundant storage in this case. All right, so yes, question?
My understanding that if you had an implementation of Azure Stack, or of Azure Pack, shall I say, of an Azure Stack's available, that you can use that deployment script into a...
Awesome question. So the question the gentleman here asked was, confirm my understanding that if you are working with Azure Stack, the Azure Stack supports exactly the same API, so that if you define a template that is initially targeting Azure, then you can port it back into Azure Stack, or the other way around. If you start targeting Azure Stack as the first deployment target, then you can push the same template into Azure. Your understanding is absolutely correct. It is exactly the same code that just lives at different URLs. I mean, the Azure Resource Manager service, the API that takes that template, will be obviously at different URLs. The one that Microsoft provides versus the one that you have deployed on premises. And you just change the URL that you push that template to. OK, so inside the template, for some more advanced scenarios, you can use a bunch of different expressions. Those are the majority of them, but not all of them. So you can do things like base64 encoding for strings, concatenation, which we have seen already, something called copy index, which I'm going to show in just a second. That's one of the very important expression types and semantics inside the template. List keys. This is particularly for things like storage accounts and anything that works really with shared secrets. Pad left, parameters we have already seen. Providers, if you want to discover what providers are available. Reference, if you have a template deployed already in one resource group, and then you are deploying a completely different resource group that potentially depends on an artifact that was already deployed. You retrieve that artifact from the other deployment using the reference function. Resource group gives you the current context of the resource group that you are working with. Resource ID retrieves the ID, which is the full URL, the fully qualified URL of the resource that you are looking for by resource name. Subscription gives you the current subscription variables. We have seen variables with default values in our simplistic template. Question in the back.
Does reference work for resources created through the service management API, not through?
So the question here is, does the reference function work for resources that have been provisioned through the service management API? The answer is no. Yes. If they have been provisioned using the classic model, you wouldn't see them through Resource Manager. So no, the answer is no. Yeah. Now, very interesting question there. So the follow-up question was, even for something like storage accounts. Storage account names are completely global, right? They have just their unique DNS name that they are addressable by. So if you're trying to create a resource using ARM, or a storage account using ARM with a given name that already exists as a storage account that was provisioned using the classic model, there will be a clash in the names, in the DNS names, right? So the template is going to error, okay? But you can't leverage the existing classic storage account as part of your template definition. All right. So the other thing that I want to say, that URL that you see at the bottom, that has an example of every single function that is available inside ARM and the templates that you define, right? In fact, the product team pushes examples into that Git repository faster than you would get any documentation published, right? Immediately, as soon as someone in the product group crafts an example for their particular service, document DB or whatever, that example comes in here, right? And then the content guys pick up the documentation, and then a few days later, you might see an MSDN article about how you work with that function. Okay, so remember that Git repository is very important for you to refer to when you need samples of how things work. Advanced template scenarios. So I spoke about extensions, and in particular VM extensions. We support desired state configuration with PowerShell, Chef and Puppet extensions, and custom script. So this is basically any PowerShell script that you want to feed into the virtual machine that was just provisioned by ARM, and then the machine itself inside the guest VM continues executing that custom script to reconfigure itself. App service. So if you want to push a website into app service/websites, then obviously you use web deploy for this. For SQL database, you have the backpack, which are basically the database definitions and data for that matter. What other advanced templates? Right, so copy function, I spoke of that already. We'll show an example of this just in a second. Nested templates, we'll talk about new or existing pattern. I'll skip that. And the reason I'm going to skip that is because you should actually avoid, as a general piece of guidance, to have conditional logic. And this is what new or existing is. It is conditional logic. Why would you avoid conditional logic? Because you are not truly declarative if you have conditional logic. Depending on the parameters, the environment, setup, and everything else, you might end up in a completely different state. And you don't want that with a declarative template which describes a desired state, right? You can't have desired state as well as conditional logic altogether mixed up. Or at least that's not the best practice. You can if you want to. All right, so that takes us to the next demo. And the next demo is to actually extend that same simplistic template that we had. Actually, let's see that it worked. Yes, it was successfully deployed. All right, so I'm going to copy-paste a resource that I had pre-provisioned, another resource type. There it is. And this is basically public IP addresses. Public IP addresses are standalone entities. They just reserve a public IP name, so to speak, and DNS record, and possibly a reserved IP address that you associate with that entity, right? The definition of the public IP address component is really easy. Do you want a static or a dynamic IP? Static being the reserved one. What is the DNS prefix of that IP address that will be prefixed, in front of cloudapp.net? So this is effectively your custom DNS prefix. And then at the front, you need to provide the name of the IP address, which is the logical entity that you are going to create inside the resource group that represents that IP address. Where things are becoming interesting in that part of the template here is that I want to provision 4 public IP addresses, right? And this is achieved not by copying the template 4 times, doing exactly the same thing, but instead you can use the copy function, which is right here, right? So the loop, so to speak, that will create 4 of these public IP address entities is called public IP loop. Right? We are requesting 4 of them. Remember that number 4 could be coming in as a parameter as well. So it's completely dynamic. You might be provisioning 100 IP addresses if you want to, or 100 virtual machines that are part of the same availability set as an example. And the name is a concatenation of a static hard-coded prefix, IP dash, the DNS prefix that we requested, which is a variable, whatever I hard-coded that as, or it could be a parameter, and then the number, the string representation of the number which is the index in the loop, the current index in the loop, right? Offset by 100. So loops usually start at 0, right? Well, when I start actually concatenating the iteration number, it is going to be offset by 100, meaning that the first one is going to be 100, the second one is going to be 101, and so on and so forth. And the reason I did it that way is that if I'm provisioning 20 IP addresses, I want a consistent length of the IP name. I don't want the first one to be name 0, name 1, and then when I reach 10, I go with one more character to the name. This way, if I'm provisioning 20 or 30 or 40, they'll stay within the 100 to 200 range, or no, from 100 to 999 range, meaning that the length of the string is going to be the same. All right, so let's push that template. Remember that templates and deployments are idempotent. So now that I extended that template with new resources, all the resources will be preserved. The new deployment is just going to inject the additions to that template. And I may have, no, it's good. All right. So we'll come back to that in a few moments. Let's not waste time just watching paint dry here. Organizing with Azure Resource Manager. Question, yes?
Can you deploy reserved IP addresses through that as well?
This is exactly what we did. So remember how?
The public, because you get 5 free public, right? But don't you have to specify the reserved ones separately?
No. OK, so with reserved IP addresses in Azure, they still need to be Azure created. Right? You can't just, and that's something that I was talking about during the networking session this morning, you can't just bring any odd IP address that you have out publicly today, right? And say, hey, this IP address is going to hit the Azure data center, because that's not how internet routing works, right? We need to issue you an Azure-owned address, which is in our address space. But then we give you a guarantee if you ask for a static address that this is not going to change. You may not have that IP address linked to any other resources. It could be just literally a standalone entity, right? Not referring to a VM, not referring to a storage account, nothing, right? But it's not going to change. And then you just assign it to whatever you need, including moving it from, you know, one virtual machine to another virtual machine in a swapping scenarios. So you could have a machine which is called production, then you stand up another machine, which is your staging. You do the testing. You are happy with it, and you go, IP address reserved. Please switch over here, right? Any clients will be seeing that IP address is static or reserved, which is the whole purpose. All right. So organizing, Bill.
Real quick one. Is there any way to run these provisioning in a test mode so it doesn't create, just checks the...
Yeah. So there is a commandlet, which is part of the ARM PowerShell API, which is called test template, which is basically a validation of the template syntax. It does not guarantee, it doesn't do a full what-if analysis, does storage accounts exist, and so on and so forth. Actually, you can do that inside the template itself, right? Does storage account with name X exist? Just as an example. All right, so organizing with Resource Manager. We explained what resource groups are. Linked resources help us nest templates. Okay, so if you want to define all your storage accounts within a resource group and within a solution in one template, but then have database servers in another template, and then the web front end running in websites in a third template, you can do that. And then you basically just do linked resources across the 3 templates and the deployments inside those templates. And finally, for organizing, you can use tags. And we are going to see demos of all of that if we have time. All right, so thinking about deployments, templates, resource groups, what are our options? The first and simplest one, you have a resource group, which is the white rectangle. Inside, on top, you have your template, which once it is pushed into that resource group, creates a deployment. And then in a single template, for this particular example, you define all the tiers of your application. You have the SQL tier, the website, the cache, or the virtual machine, whatever we've got, right? And obviously, in this case, the application or the website template needs to have a reference to your SQL database. This is achieved by calling the reference function once the SQL database is provisioned, right? Remember that in the template, we looked at a tag called depends on. Yeah? So you can basically say that the website depends on the SQL database being provisioned. So ARM is smart enough to create a dependency tree once you push the template in and go, OK, I actually need to provision the database first, and only after it's completed and successful, then I can move on to the website. Okay? So you use depend on and reference in combination to create that relationship and sequence during the provisioning. So this is the simplest way of defining all the resources inside a single template. Another approach that you can take is that within the resource group, you are going to define 3 completely independent templates, right, that each provisions an artifact of a given type, or a subset of artifacts, depending on how you decide to structure the whole thing. Maybe you are going to put all the PaaS components in the face of SQL DB and the website into one template, and then you're going to have an infrastructure template which hosts the virtual machines and provisions the virtual machines. Okay? Remember that resources always live in just one resource group. Okay? This is an important principle. And respectively, when you deploy this whole thing, right, all these 3 deployments in the picture, they need to be pushed into a single deployment group. Nested templates, okay? So you can create a parent template which says, I'm not going to do anything. I'm just going to invoke the first template and the second template and the third template. Okay? This is what nested templates refers to. So in that scenario, I may have gone and provisioned the virtual machines already, right? And then an app developer, for example, goes on and says, OK, I depend on those virtual machines. Therefore, I'll include that deployment template as a nested template into my template. But I'm also going to add another couple of templates, one describing the SQL DB and the other one describing the website. This becomes your parent template with 3 nested templates. We'll push that into the Resource Manager API. It will discover that the first template, being the virtual machines, has already been provisioned. It will skip it, and then it will provision the other 2 resources, which are the database and the website. Okay? So this is the idea behind nested templates. If you want to break away from all the artifacts living in different resource groups, then you need to basically do this, and there is no nesting in that scenario. Okay? Now, your virtual machines tier itself in that resource group here might be actually composed of nested templates, one of which provisions purely the virtual network, and then the other one bolts on the virtual machines on top of the virtual network, right? Still part of the same resource group, right? But then when you start looking at the app tier and the SQL database, they need to live independently in their own resource groups. And the way that you link the provisioned resources is again through references. OK, so the next one, which is an easy concept, is tags. With resource groups, now you can basically tag or associate name-value pairs with any resource. Okay? Literally any resource that you deploy in Azure, whatever it is, you can put up to 15 tags. And you can use them for anything. You can use them for designating the resources belonging to the finance department, another resource belonging to the HR department. At the same time, those 2 resources are both tagged as development resources versus test resources versus production resources, and so on and so forth. And you can report on that later on. So an extremely flexible tagging system, effectively. So this is what this refers to. We just explained that. And why don't we go and see that in action? Our deployment succeeded. If we go off here and refresh that resource group, we are going to see all the resources that our template provisioned, including the 4 IPs. And you can see the naming convention, which was based on the copy index function, right? Starting from 100, 101, 102, 103. All right, so what were we looking at? Tagging. OK, so let's have a look at the virtual network, for example. The first thing about tagging is that you can do these things through the portal. OK, each resource that you look at has this little tag icon there. You click on that, and hopefully, if I configured everything correctly, there is the display name of the resource, which was VNet, and our dynamic parameter that we fed into the template during provisioning time. I used the default value for that parameter, which was dev. It could be test, it could be production, it could be staging. All the artifacts in that resource group that have just been provisioned are going to have that tag. Speaking of the ARM API and tooling in terms of Azure CLI tooling and PowerShell and stuff like that, it's your choice how you work. Obviously, at the moment, we are in the portal, but we can go and get information about the tags using PowerShell. So I'm just saying get tag. We can see that there are 2 tags all across the subscription. This is subscription-wide. Okay, so the first one is called display name, which is associated effectively with all the artifacts. 25 occurrences of that, 25 resources have that tag set to a value. And then 6 resources, which are our 4 IP addresses, the virtual network, and the storage account, have the environment tag. And then if I'm after more specific information, I can add the detailed parameter into that same command, and I'm going to get all the resources that have the display name set along with the value of display name, and the resources that have an environment tag, 6 of them are set to development. Okay, going back to the scripts, you can actually get the actual resources that was just displaying us information about occurrences of a given tag with a given value. Now I'm saying through that PowerShell commandlet, get the Azure resources that have the tag environment with the value development or dev. And here are our 6 resources with some details. You can see the resource ID, which is the longest parameter or property here. That's the URL that I was talking about. It's a relative. And then names, resource group, deployment region, and so on and so forth. What is interesting is that you can use this approach. So in that, actually, let me bring that into a bigger font. I'm not going to run this because this is going to kick off a download of a fair chunk of data, right? Here we are saying, find out all the resources that have environment set to development, and then get the usage metrics, right, which is another PowerShell related to the ARM API, get the usage metrics for each one of those resources. I have just created a report that gives me the cost, or well, not the cost necessarily, but the utilization or the usage of all my development resources. So I know what my development environment now costs. Fair enough? Any questions? I'm going pretty fast here. I'm trying to cover as much as possible.
It's a declarative template, right?
Yes.
If you want, I don't want IP anymore. Like you have 4 and you want only 3 now.
OK, so I know what you're asking. So the question is, what if you want to delete or remove resources from a template? The template is not about that. OK, so once a resource is provisioned, you can't manage it, or you can't delete it, at least, through a template. You need to use imperative commands through PowerShell or Azure CLI commands to remove the resource, bottom line.
No risk that I run a nested template for getting one template and delete a machine, right?
Yeah, you basically need to go against the resource itself individually. Yep, cool. All right, so that was about tagging. Hopefully, things are clear now. The next one, which is playing into the control space, an important topic is role-based access. Okay, and that has been asked for months, years now. Role-based security on top of Azure resources, right? Resource groups and ARM make that possible. We'll talk about that in a little bit more details. Then you can get audit logs, which is somewhat based, related to role-based access. So you can get full audit log of what commands have been performed through the Azure Resource Manager API. Modifying resources, creating resources, deleting resources, who has performed a given action. This is all through audit logs. And the last topic in that area of control is that you can basically declare that a resource is locked and literally nobody can delete that resource. So a mistake cannot happen. Okay, that brings the question, what if I want to delete a resource legitimately, right? You need to first remove the lock intentionally, which is going to be audited, and then you need to perform the delete command against that resource. Okay? That's the idea. OK, role-based access. Granular permissions, at the end of the day, to resources. I mean, the concepts are clear, I would think. The only thing that I'm going to say is that you define roles, called role definitions in ARM. You attach permissions to those roles. And then you attach either users out of AID or security groups, user security groups out of AID to those roles. OK? That's pretty much it. So what I would like to do is actually jump into the demo. Actually, no, before jumping into the demo, there are predefined roles that come with ARM already, right? We started out with just three of them, owner, contributor, and reader, right? Now we started for each different resource type, such as virtual networks, virtual machines, storage accounts, to add customized, Microsoft customized additional role definitions, such as network contributor, right? So if you are a network contributor, you can't go off and delete a storage account or create a storage account. You can only manage networks, okay? In the fullness of time, we are actually going to allow customers to define their own set of permissions into a role definition and attach users and user groups to that role definition. And you can actually see glimpses of that already happening in the ARM API and PowerShell commandlets. I don't think that we'll have time to, actually we might have time to look at that as well. But for the time being, just assume that you are limited to the Microsoft-defined roles of owner, contributor, reader, and then the resource-specific roles that we already have in the platform. All right, with that said, this is, I'll talk about that as we go through the demo. OK, so let me clear the screen a little bit here. RBAC. The first thing is to look at what role definitions already exist. This is Microsoft-defined roles, OK? API management service contributor, application insight component contributor, automation operator, BizTalk contributor, classic network contributor, blah, blah, blah. Owner, reader towards the middle. And the last one is website contributor, right? So bottom line, this is the all the definitions, role definitions that you can currently work with. The next thing comes to mind, OK, I see that there is a role called network contributor, but what does it actually allow me to do? So now we are saying, get the role definition with a name network contributor and show me the actions that can be performed by that role. I'm only interested in the first two because the rest are somewhat system permissions that you need for pretty much any role. The first one says that you can perform asterisks, meaning a pattern, everything, from the Microsoft.network resource provider. So you can use the network resource provider to define virtual networks, define subnets, delete subnets, update subnets, IP addresses, whatever. Everything that is covered by the network resource provider. You can also authorize and effectively get tokens, access tokens, from the Microsoft.authorization resource provider. So you can authenticate to the service. Okay? Those are important. And of course, if you don't want to define a network contributor, you only need a network reader. When we allow you to define custom roles, completely custom roles under your control, instead of going Microsoft.network/star, you would go Microsoft.network/star/read. Meaning that IP addresses, virtual networks, subnets, load balancers, whatever, you can read, right? But you don't have a write or delete permissions, which is currently the case with Microsoft.network/star. OK, so the next step from here, I'm going to go and retrieve the object ID of an AD user, which is myself using my Google ID. Well, that's a Microsoft ID, to be precise, linked to my Google email account. So that object ID is required for you to link a user to a role definition. Okay? And this is our next step, which basically says, OK, I'll take this command here. OK, so new Azure row assignment, which is the link, the membership definition effectively. In the resource group code ignite.arm demo, the user with mail address blah, add them to the row definition of network contributor. Actually, before that, I hope that the command is not as fast as the refresh of the screen. Please. No, it would have already happened. Maybe not. Or it has. Where are we? All resources. OK, so let me just have a look at something. Browse all. We are going to look at resource groups. OK, actually, no, let me add a reader as well. Eventually, we'll get there. There we go. All right. OK, so the idea here was that the identity myself with Gmail registered, I wanted to see the virtual network that was provisioned in the ARM template. I must have misconfigured something. Let me just browse all one more time. Yeah, it should have been here. All right, we'll leave it. But you get the idea. I basically assigned a completely external user from my organization, someone with a Google email address registered with AAD, to a subset of the resources that I have. So it might be an outsourced support provider, for example. I only gave them permission to manage my network, but I don't want them to see my virtual machines and be able to log in or delete virtual machines and so on and so forth. The only thing that they can change is reconfigure the virtual network. OK, so the other interesting thing that we can do here is when you get to define your own custom roles, it is not quite there yet, as I said, you are wondering probably what are the actions from each resource provider that you can use. And this is that commandlet, get Azure provider operation, give me the action string, and I'm exporting that to a CSV file here. Has that happened, really? No. Now it is happening. All right. There we go. So if I'm not mistaken, I got the actions from, yeah, right. So I got the actions from every provider in Resource Manager. I could have limited that to storage. If I'm interested in only defining storage administrators, I could have well done that. All right, let's go back to the demo. Audit logs. Not much to say here. Apart from that, it is an audit log, and it has entries for every single action that is performed through the Azure Resource Manager API and providers. And there are multiple ways to look at that data, of course, as with anything else. So if we go to Browse All, you have audit logs right here. And then you can use a filter to say what exactly you are interested in. And you can basically go, show me a particular subscription or multiple subscriptions. What is the resource group that you want the audit log for? What are the specific resources? You can choose the storage account, for example, and so on and so forth. Update the filter, and it will give you information about those activities. At the bottom, you get granular view of exactly what activities have happened inside that scope. In our case, this is the resource group that we just put in the filter, right? And you can click on this and get the detailed information when the operation was started, when it succeeded, who performed it, what resource it was performed on, everything that you would expect out of an audit log. The second way that you can work with it, of course, is the PowerShell and CLI tools. So I can basically go and say, get me the resource group log for a resource group called Ignite Networking. You can limit by start time, and I'm going to export that. Okay. Oh, by the way, here I'm saying where the resource ID is or has storage in the resource provider name. So in other words, I'm saying, give me an audit log for all these storage-related transactions that have happened. So we'll run this. And once the command succeeds, okay, here is the Excel file with everything that happened. This is the old Excel file that we have been looking at. Read only, that's fine. Okay, so you can see the caller, that's myself, the scope, which would be the storage account called EV Ignite Storage, the status of the operation, succeeded, started, and all of that, time of the operation, subscription, and all that. So you can basically download, filter the data, and do whatever analysis you want on top of that. Okay, simple as that. Not going to waste any more time on this. And that was the demo. Resource locks. Okay, so I already explained what a resource lock is. It is just a stamp to say a particular resource or even an entire resource group is locked for deletion. Okay, and then if you want to really delete something inside, you need to remove the lock explicitly and then perform that deletion operation. Again, I'm going to show you PowerShell script-based locks. In fact, you can do the locks declaratively as well. This is exactly what this thing does here. That's an extension to my deployment template. I'm just going to paste that here, and let's work with this. So we are basically saying that on top of that storage account name, which was the concatenation of the deployment environment and the storage name, right? This is the resource that I want to create, which is of type locks. The level is cannot delete, which is the only level that we currently have for locking. And it depends on the storage account being provisioned. So if I, obviously, because to create a lock on something, that something needs to exist, right? So I'm going to just go ahead and run that template again. This is the incremental difference in the template. So the resource lock is going to be created shortly, if not even there. Oh, no. So to Bill's question earlier, the template is currently getting validated. That validation happens in line here. And eventually, we'll see a line that says, there we go, template is valid. And now we are going to proceed with the real deployment. So once that's done, hopefully very, very soon. So virtual network succeeded, IP addresses have succeeded, storage account succeeded. Right, so now the lock has just gotten created. And if we go back here into our ARM demo resource group and try to delete this guy. In fact, we don't even have the delete link here. There we go. Actually, no, this is type the storage name. Storage name is this. Let me copy that. Delete the empty space. Come on, what is happening here? Anyway, if I try to delete it now, it will just come back with an error and say the resource is locked. And then I need to remove the lock and delete the resource. The concept is fairly simple, right? And that, ladies and gentlemen, I think takes us to the end of the session. So that was the demo on resource locks. I'm late by 4 minutes. Go ahead and try templates. That will be my only ask of you. This is the way forward to working with the platform. Extremely powerful way, extremely repeatable as well, because remember that templates are a desired state, and they are cookie cuts. So use parameters wisely so that you basically, solely based on parameters, provision different environments. or different stamps of your application. It might not be necessarily just different environments, dev, test, and production. It might be, European stamp and Australian stamp and North American stamp and so on and so forth, right? You're guaranteed to get exactly the same thing. Cool. All right. Thank you very much.